This question is asking us to solve for the force parallel to a 20-degree ramp required to keep an 80 kilogram mass at rest, which means that F net equals 0 if the frictional force is 40 newtons opposite to the direction of the applied force. So let's start off by drawing a diagram. So we have our horizontal plane here, and then we have our ramp up like this, and the question states that that's at an angle of 20 degrees. So we then have our object. It's going to look something like this. We have our force of friction. We have our applied force, which is equal and opposite in direction. We have our normal force, which is perpendicular and opposite to the surface. And then we have our force of gravity, which again is just straight down regardless of the angle. But our Fg gives us two components. We have our component opposite to Fn, and then we have our component parallel to the plane. And of course, this angle in here, angle theta, is equal to 20 degrees. So now that we have our free body diagram, we can then start doing a little bit of math. So we know that F net is equal to 0. And here we're just going to solve for the sum of the forces parallel to the plane of the ramp, and then the sum of the forces perpendicular to the plane of the ramp. So this is going to help us solve for ultimately the force that we're looking for here. So if we know that F net is equal to 0, we also know that the sum of the forces parallel to the ramp are going to be equal to 0. So what are the forces parallel to the ramp? Well, we have Fa, which is the applied force. We have F of friction, which is in the opposite direction, so we're going to give it a negative sign. And then we have the parallel component of the force of gravity, which is also in the opposite direction, so we're going to give that a negative sign as well. When I rearrange this equation to solve for Fa, I'm left with Fa equals Ff plus Fg sine theta. And then I can start to kind of substitute in things that I know. I'm just going to break down this Fg a little bit more. So we know that Fg is mass times force of gravity, and then we have our sine of the angle. So the force of friction given to us in the question, 40 newtons. The mass also given, 80 kilograms. We know our force of gravity, 9.8, sorry, that should be kilograms beside the 80. 9.8 newtons per kilogram, sine 20. And then we can solve all that in one step. That gives us 308 newtons. And the direction of this is parallel to the ramp. So parallel to ramp. That's our Fa. We also want to know Fn. So Fn is going to be, if you wanted to solve for Fn, the question just asks for the applied force. But you can take this one step further if you want to solve for what the normal force is. This case, we're looking for the sum of the forces in the perpendicular direction. So we know that that's 0. That's just Fn minus Fg cos theta. And of course, this makes sense because our normal force is always equal and opposite to the component perpendicular to the surface of gravity. So that's 80 kilograms, 9.8 newtons per kilogram cos 20, which gives us a normal force of 737, and that's perpendicular to the ramp.